For part B, a lot of students make the mistake, because they think that these are always going to behave as regular functions in their inverses do. And unfortunately, with those range restrictions, that's not the case. The reason being is that, like most of the time we would say, well, the arc cosine of the cosine, so the arc cosine and cosine would just cancel, the answer is 7 pi over 6. A lot of people think that. Unfortunately, that's not the way it works, because arc cosine, the second function I would actually be evaluating, would never return a value of 7 pi over 6 because it's over pi. So when I do the cosine of 7 pi over 6, I get negative square root of 3 over 2. When I do the arc cosine of negative square root of 3 over 2, that would give me 5 pi over 6. And that is what the answer would be. So those range restrictions can sometimes cause things to react a little differently than you're accustomed to for other circumstances. When I deal with functions and their inverses. The sine of the arc cosine of negative square root of 3 over 2. Well, the arc cosine of negative square root of 3 over 2 is going to again be 5 pi over 6. When I do the sine of 5 pi over 6, I get a positive 1/2. For part D, the tangent of the arc sine of 3/5. Now again, 3/5 is not a ratio that I'm used to seeing on my chart of special angles. But yet, it's in the section that says do not use the calculator. So there has to be a way for me to answer this. Because a lot of students, what they would try to do is they would do the arc sine of 3/5, get some nasty decimal number, do the tangent of that nasty decimal number, and give an answer. The problem is, when you're doing that, you're often going to be rounding, because that nasty irrational decimal number, a lot of students round that off, and when you round that off and then take the tangent, that's going to cause it to be off a little bit. So the fact of the matter is you do a problem like this, you don't necessarily have to figure out what the angle was. If I'm doing the arc sine of 3/5, it's telling me I have an angle, which I'm going to call theta, and that's all I'm going to call it, and its sine is 3/5, so I set it up to be that. Now, I put it in the first quadrant because that theta does have to be between negative pi over 2 and pi over 2, which would put me in the first or fourth quadrant. And the first quadrant is where the sine is positive, and the fourth quadrant would be negative. So I'm drawing it in a position based off of what arc sine would give to me. Well, from here I can figure out what the remaining side is. It's 4, and then I'm going to do the tangent of theta. And the tangent of theta is 3/4. And that's done. I don't have to figure out what theta is to answer that problem. And a lot of times when you're given a situation like this, you don't have to figure out what the actual angle was. So keep that in mind.